Gentlemen, Mr. Callen here to help you with lesson 2-9, solving multiplication equations. And I want you to realize where we've been, where we are now, and where we're going. We have been computing products and quotients of whole numbers and decimals, all in the sake of helping us with some algebra. Now we're going to have some multiplication equations, and that's our goal for today. I will use algebra to solve one-step equations. Now, lest you think this is too easy, eventually it'll get to two-step equations. That will be equations that will have not one but two terms, and we need to solve that. Sooner or later, you'll get to multi-step equations. You might even have variables on both sides. So let's focus on one-step equations for today and really using our algebra steps to help build those building blocks. Now, whatever the date is today, go ahead and write name, date, period. Whatever the assignment is, it might be assignment 12, might be another assignment. Go ahead and write what you need. Pause your video. Come on back when you're ready. Don't forget, ladies and gents, we're getting back into equations, so make sure you're writing problem, work, solution, and your check step. More about that in a second. Now, we have already learned how to solve and model equations, mostly with addition and subtraction. Imagine a teddy bear. We don't know how many baseballs that is. If you were to note that this equation, you can see that we have one missing piece and another 5, so that explains the x plus 5. All that is balanced and equal to 7. How do we get rid of that? Well, to get rid of that addition of 5, we would subtract 5. Of course, we would subtract 5 from both sides of that equation to keep it fair and balanced. We showed that by either taking away or drawing that subtraction of 5. Naturally, you'd get x must be 2. And of course, we must check. Now remember to check. All we do is we take the original equation, but now instead of writing x, we believe we know what x is. We believe x is 2, so we substitute in 2 and really check to make sure it is a true statement. Anybody can come up with an answer, but a solution is a number or numbers that makes a statement true. All right, so we've done that with addition. We've done this with subtraction. How about with multiplication and division? Let's try to model 2 times x equals 8. And let's use one of these blue blocks to imagine that each of those is an x. So we don't just have a single x, we have not one, but we have 2 of them. And on the other side, it is equal to 8 cans. So I'm going to go ahead and draw 8 cans. And as you can imagine, you can use your little algebraic sense to say, well, look, if 2 of those blue boxes are equal to 8 soup cans, then each of those 1 boxes is equal to 4. That's how we would model it, ladies and gents, by just simply splitting it into groups and seeing how much each x is worth. Let's do a different one. And let's write an equation, model the equation, and solve the equation. We have 3 packs of M&Ms, $6. Question is, how much will each one cost? So let's go ahead and say P is a pack of M&Ms. Now, I'm going to go ahead and model that first. They said we have not 1, not 2, but 3 different M&Ms. And 3 M&Ms is equal to $6. So let's go ahead and write that with numbers and symbols here. 3 different P packages is the same as $6. Naturally, we can then use our number sense, use our algebraic skills to say, all right, well, let's see. Each of those packs each of those packs has to be $2. Now, folks, that's all fine and dandy, but what if instead of 3 packs, we had 33 packs? What if instead of $6, it was $106? We don't really always want to set up a model, draw it out. So sooner or later, we have to solve it using numbers and symbols. So let's imagine 5 packs of M&Ms, $35. We don't want to know what 5 packs are equal to. We want to know what a single pack is equal to. So what did we do before? Well, we split up each of those into groups. And in this case, we don't have 3 packs of M&Ms, we have 5 packs. So we would split up both sides into 5 groups. Now I want you to imagine what we have here. If you split up 5 packs into 5 groups, what's 5 divided by 5? Well, it's a single B, and I would venture to guess that you will not write the 1 next to the B. You may if you wish, totally your call. Meanwhile, if we also split 35 into 5 groups, we'd find each must be a fundraiser pack, must be $7. So that is how, ladies and gents, that we show the splitting or division using numbers and symbols. We're going to show that not just on one side, we're going to show the splitting up on both sides, divided by 5, divided by 5. And again, to remind you, you may write this one or you may choose not to. Now don't forget, we also need to check it. So I'm going to rewrite the equation. 5 times some missing number b equals 35. I just take the original equation. But now we don't think that b is unknown. We think b is known. So I'm going to substitute a little 7. Now, many of you, I even suggest, so that you don't kind of cheat your brain, you even cover that side up with your hand and say, okay, 5 times 7, 35. Aha! 35 is the same as 35. I'm going to write true. Some people write a check. Once again, notice what I'll repeat myself. Problem, work, solution, and the check step. All right, more on that as we go. Let's do a few more without drawing models. In other words, we're just going to use numbers and symbols. In problem number 1, we have 3 times n is equal to 39, but I don't want to know what 3 times n is. I want to know what a single n is. So naturally, we're going to split it into 3 parts, just like we had those 3 packages of M&Ms. Oh, got to be fair to both sides, right? To re-emphasize that 3 packs of n split into 3 parts is a single n, and no, you don't have to write the n. That is your choice if you do or not. Meanwhile, 39 split into 3 parts, 13. Don't believe it? Then go ahead and check it. Recopy the equation. 3 times some n is equal to 39. But now we believe we know what n is. We believe n is 13. Some people will put a little question mark there. If you need to, cover this up so that you don't cheat your mind. 3 13s is 39, which of course makes a true statement. Now, here's what I don't want to see, because I want you to look at this and see what I've been talking about. We have the original problem, we have work, we have solution, and we have the check, right? I don't want to see anybody jump right into the work step, because in that case, it's hard to tell, especially when you start crossing things out, what the original problem was. So leave the original problem just as it is. Now recopy it and say, no, I don't want to know what 4 t's are. I want to know what a single t is. So now let's go ahead and split or divide each group, each part of the equation, into 4 parts. Because multiplying by 4t and dividing by 4t are inverse operations. After all, 4 divided by 4 is 1. And again, you could keep writing the 1, but I'm going to get rid of that. In this case, a single t is equal to, use some mental math there. What if I messed up? What if I said it was 40? Now I'm going to come down here. I'm going to show you the power of checking. So recopy the equation. But in this case, we believe t to be 40. A little question mark here. Cover this up so you don't cheat your brain. I have had people write 4 times 40 equals 164 and just put a check there. To which I would respond, that is fake checking. You didn't really check. Because if we would have multiplied 4 times 40, we'd get 160. And this is a false statement, ladies and gentlemen. 160 is not the same as 164. So please be careful and use that check wisely. Don't fake check, actually check it out. Now in this case, I believe that 164 split into 4 parts is 41. So if I recopy the equation and substitute in what I believe is the solution, cover that side up, 4 times 1 and 4 times 4, now that looks like a true statement. So no fake checking. Once again, to reemphasize, problem, leave it alone. Then write the work step underneath that, circle your solution, and check to make sure it is a true statement. Let's make things a little more challenging, shall we? We got 2 envelopes full of money, $4.80, but I just want to know what a single envelope is. So naturally, let's split each of those into 2 groups. 2 B's split into 2 groups is 1. Again, you don't have to write the 1. $4 split into 2 groups is 2 whole dollars. 8 dimes split into 2 groups is 4 dimes. Or is it? We can always check to make sure we have a valid solution by recopying the equation, substitute in the number, cross off if you need to. 2 sets of 2 is 4, 2 sets of 4 tenths is 8 tenths, and that appears to be a true statement to me. This case, this one's a little trickier because instead of multiple envelopes, let's see, we got 1, 2, 3, $4, maybe 2 dimes. Instead of multiple envelopes, we have a part of an envelope. We only have 1/10 of an envelope, but I don't want to know what 1/10 of an envelope is. I want to know what a single envelope is. 1 whole envelope. That's okay. What we're going to do is we're still going to split it up. In fact, we're going to split it up into parts of 1/10. It's almost like we split it up into groups of dimes. Any number divided by itself, still the 1. You don't have to write the 1, but you may if you wish. And use a little mental math here. Essentially, what we have to do is to change that divisor to 1 whole. Oh, snap. 42 split into 1 part is 42. Don't believe it? Come on down and check it. Recopy the equation. Substitute in what we believe it is. 42 times 1 is 42, but with 1 decimal place moves to 1 decimal place. And we see it's true. Once again, ladies and gents, you will see on each of these problems, look how they're similar. They all have the problem left alone. They all have a work step. Inverse of multiplication is division. They all have a solution that is circled, and they all have a check. How are they different? Well, they have different numbers, surely. Green problem, we have to divide by a whole number of 2. Blue problem, we have to divide by a decimal. But we know how to divide by whole numbers and decimals. Let's carry you through into some word problems, ladies and gents. So here we go with a hot air balloon flew at 10 miles per hour. Using the variable h, write and solve a multiplication equation to find how many hours the balloon traveled if it covered a distance of 70 miles. So all I'm seeing is balloon travels here, balloon travels here, balloon travels here. In the end, it's going to be 70. Now, firstly, I read through the problem just to see that I understood it. Then I go back and ask, what is the question asking? Because it says how many hours, that's what I'm going to let my variable be. Let h be the number of hours traveled. Now, what else is important information? Flew at 10 miles per hour. Now listen, remember that per basically means multiply. Otherwise, what you have here is 10 plus another 10 plus another 10 plus, well, we don't know how many tens. So we can say 10 times h hours. You may use the dot, you may choose not to. In the end, it covered a distance of 70 miles. And I'm going to trust that you guys know how to solve it from there. I think that's the most important part. Taking the words and writing it into mathematics, taking the verbal sentence, creating a mathematical sentence. So notice that we define a variable, h is hours traveled, and then we wrote an equation, 10 times h hours is equal to 70. From there on, you can solve it. Let's do that a few more times, as a matter of fact. If you wish, pause the movie, pause the video, read through this, try to decide which of the bottom equations will match up with each piece, and then unpause and go from there. All right, let's start. $7 per hour. There's that per again. $7 per hour. Total of 21. Which of those will match up to it? Instead of using H, they use X that they didn't give it away. And so there goes the first one. Take a look at the second. 18 moons. Oh, snap, 2 times more. So anytime you think 2 times more, you're thinking 2 times more than Neptune. So which of those says 18 is 2 times Neptune? That would be this equation right here. Instead of using n, they chose x, not to give it away. Last but not least, Distance between Little Rock and Benton, 24 miles. Triple, there it is again, triple the distance of the other. So if I'm going to do triple, whether or not use the x, it's going to be 3 times x is 24. Which of those says 3? Ah, there she is. And so that, ladies and gents, is a little more practice with how to convert verbal sentences into algebraic sentences. From there, go ahead and just solve it using your algebra steps, and remember to check it. That's what I have for you, folks. Go ahead, get back into your homework, do well, and let's grow. See ya.